Unit 4, Day 2, and we get to do some algebra. It doesn't get any better than this. So, first of all, it says expand and simplify. So my goal on this first slide is to go from vertex form, and when it says to expand and simplify, I'm going to get rid of my brackets. So I'm headed to standard form. I know that I have vertex form right now, so I know with this particular parabola that I'm starting with that my vertex is positive 4, because I have x subtract 4 in the brackets, and up 3. So to do the algebra on this, my best hint to you would be, when you see x subtract 4 squared, write it out twice, because that's what squaring means. X minus 4 multiplied by itself twice, and then later on add 3. We make less boo-boos if we don't try and do FOIL in our heads. So I'm doing a multiplication between the brackets, so I am going to end up with first x squared, outside, these two guys, negative 4x, inside, negative 4x, lasts, positive 16. I know you're good at this. We're just going to practice quick. So I'm going to collect like terms. I have x squared. I have two piles of x's. Altogether, I have negative 8x. And my numbers I can put together and get 19. So what that tells me in standard form is that I have a y-intercept of 19. Okay, the second one, same idea. Y equals 3 times x minus 1 squared subtract 5. We've been asked to expand and simplify, so I'm heading for standard form. So let's just write off to the side here what I know. I know my vertex is positive 1, opposite to what you might think, down 5. So to expand, my hint would be write it out twice. X subtract 1 squared means two of those. The 3 isn't squared, just the bracket is squared. So if I write it out, I know that I have got 3 times x minus 1 times x minus 1, subtract 5. So my thing is to leave the 3 till later and do FOIL on the two brackets. Deal with the negative 5 last of all. You just make less errors that way. So x subtract 1 times x subtract 1 is x squared. I'm doing FOIL again. Subtract 1x plus 1. You could deal with the 3 now, or you could tidy up that bracket first. I'm going to tidy up the bracket first because I've got two piles of x's. So I've got my x squared term. My two terms with x would give me negative 2x plus 1. And now I'm doing distributive law with the 3. So I'm multiplying that 3 by each of the terms in the bracket. And I would get y equals 3x squared, subtract 6x plus 3, and finally subtract 5. Almost done. The only thing that I can collect now is the two numbers on the end. I've got an x squared term, an x term, and two numbers that give me negative 2 in total. So this tells me, standard form, tells me that I have a y-intercept of negative 2. So if we were to write it as a point, it would be 0, negative 2. Both of them show me that I have that initial value of 3, which tells me that it opens up. It's kind of skinny. We call that a vertical stretch, factor 3, which means that when I am doing my step pattern, everything gets tripled. So for instance, the first step would be from the vertex over 1 up 1 normally. This one would be over 1 up 3. Okay, now we get to go the other way. Write each of the following in vertex form. In order to go from standard form to vertex form, we complete the square. Sounds fancy schmancy. Okay, we have looked at this before and it went swimmingly well. So I can only model the way my mind works, which might scare you just a little bit. But I would look at that thing and say, I know what I want it to look like. I have the exemplar up at the top. I know I want it to have a bracket with a square. So that's my goal. Oh, I didn't leave much of a space for an a value, but this one only has a 1 in front, so I don't need to worry about that just now. But I know that I want x add a number or x subtract a number in a bracket squared. That is always x add or subtract half of the middle term. So it's going to be x subtract 7 squared. So now that I know my goal, I go back up to the second line and I say, golly, if I actually had x minus 7 squared, that means x minus 7 times x minus 7. I'm just doing some rough work over to the right here. That would be x squared. Subtract negative 7x and negative 7x is negative 14x. Bingo, that's what I wanted. Plus 49. So this is the same as this. So line number 2, I am going to write down x squared. Subtract 14x plus 49. You can't just willy-nilly add a 49, so I'm going to also subtract 49. Don't forget I had plus 38. Okay, regroup. The first line, x squared subtract 14x plus 38. The second line is the very same thing, except I have added 49 and subtracted 49 to the equation. That doesn't change anything. So far, so good. My third line, x subtract 7 squared is these three terms. I showed you that over to the right. Now I have some leftovers that I'm going to put together in a pile. Negative 49 and positive 38 is negative 11. I'm done. It's in vertex form. It's in 2 colors, but it's in vertex form. So y equals x subtract 7 squared subtract 11 tells me that I have a vertex of 7 comma negative 11. All right, let's try the next one. X squared plus 4x plus 10. I know that my goal is, so I'm going to skip a line, my goal is x plus a number squared. That number is always half of the middle term. So it's going to be x plus 2 squared. Cool. That means I need to introduce a special number into my equation. I'm going to both add it and subtract it. That special number is whatever my last is when I square x plus 2 squared. X plus 2 squared is x squared plus 2x plus 2x plus 4. That is the number I really wish I had. So I'm going to introduce it to the equation. X squared plus 4x. Let's put in that wonderful 4 and also subtract it. Plus 10. I'm almost done. So line 1 is identical to line 2, but line 2, for some random reason, I added and subtracted the same number. Line 3. The first 3 terms, x squared plus 4x plus 4, is this beautiful x plus 2 squared. My last 2 terms are like the leftovers. Negative 4 plus 10 is 6. So the first 3 terms get caught up in x plus 2 squared. The last 2 terms are the leftovers plus 6. I have it in vertex form. Okay, x squared, subtract 10x plus 11. I'm going to skip a line. I'm going to write down that beautiful square that I'm looking for. It's always going to be x and half of the middle term. So I know that's what I'm aiming for. I'm going to go back up to line 2 and introduce a number, both adding it in and subtracting it, so that I'm not changing my equation. My second line is going to be x squared, subtract 10x. The number that I'm going to introduce into my equation is 25, and also subtract 25. Don't forget that, plus 11. Okay? So the first three terms, x squared subtract 10x plus 25, is x subtract 5 squared. And the last two are the leftovers, minus 14. I'm done. Two more that are a little bit more interesting. A couple of you had tried some of those the other week. We're going to do it here as well. The first one, I have it in standard form. But I see that 2 is a bit of a problem. I don't quite know how to complete the square with that 2 in the way. So I am going to factor out a 2. And I did check. 2 goes into all three terms. So I'm going to factor out a 2. And then I'm going to complete the square with what is in brackets. So if I factor out a 2, I have x squared for my first term, subtract 3x for my second term, and plus 4 for my third. Okay. Now we're going to complete the square with what's in brackets. So I'm going to keep writing my 2 over and over again every line. Okay. X squared, subtract 3x plus 4. If I want to complete the square, I'm going to skip a line and write down what I am aiming for. I am aiming for this beautiful square. X subtract, oh no, what's half of 3? 1.5. So it can be ugly and still be in vertex form. So I know when I've skipped my line and written down that beautiful square that I'm aiming for, I need to go back up and introduce a beautiful square number into my equation, both adding it in and subtracting it. What would that beautiful number be that I need to put into the equation? Well, that number is whatever 1.5 squared is. Happens to be 2.25. Okay, you ready? Back up to line 2. X squared. Subtract 3x. Let's put a 2.25 in there. Looks like Christmas. Subtract 2.25. Don't forget the 4. Close your bracket. Line number 3. Let's put that all together. My x squared subtract 3x plus 2.25. Let's just sneak another color in here. These three guys are this beautiful square. The other two are the leftovers. So I have a 4 and a negative 2.25, which would be 1.75. Now remember, all of that had been in brackets after the 2. We're almost there. That doesn't quite look like vertex form. And the reason it doesn't quite look like vertex form is we have that extra set of brackets there that I had to put originally when I factor out the 2. So I like to get rid of that extra set of brackets because I want it to look like vertex form. So it's these two guys that I don't really want anymore. So I'm going to do distributive law with the 2. I'm going to multiply it by my pretty bracket, and I'm going to multiply it by that. Final answer. 2 times x subtract 1.5 squared plus 2 times 1.75, which would give me 3.5. There it is in vertex form. It's an ugly vertex, but we followed all the same principles as before. We will have a to the right 1.5 and an up 3.5. And this one opens upwards and has a vertical stretch factor 2. Very last one. Oh, I lied. There are 2. Okay. The middle one, I have not seen a negative at the beginning before, and I'm not so sure that I like it. So I'm going to do the same thing that I did last time, where I take out that negative sign, and we'll deal with him later. So in my brackets, I'll have x squared. Now it's negative 3x negative 2. If I want to complete the square on that thing, I am going to pause. Okay, I am going to skip a line and write down half of the 3 in my beautiful square. That means I have to go to the line above it and introduce a number, both add it in and subtract it. Happens to be the same as last time. So x squared subtract 3x. I'm going to introduce a 2.25 and subtract 2.25. Don't forget to subtract 2. Okay. Line 1, check. Line 2, check. Line 3, halfway there. Okay, here we go. The first 3 terms, x squared, 3x, and 2.25, are same as x minus 1.5 squared. The other 2 things go together like leftovers, negative 4.25. And don't forget, all of that had been in brackets when I factored out a negative. So if I want it to look like vertex form, I have one more step where I get rid of those outer brackets by doing distributive law. Final answer would be y equals negative x subtract 1.5 squared, and then negative times negative 4.25 will be positive 4.25. Last one for real. 2x squared plus 5x subtract 1. That is really ugly. First thing that I don't like is the 2. So I'm going to factor out a 2. Okay. So I have x squared plus, I'm going to have a 2.5x subtract, you could put a half or 0.5. The next thing I'm going to do is skip a line, keep writing my 2. I'm going to skip a line and write down that beautiful square that I'm aiming for, which is going to be half of the 2.5. So it's going to be x plus 1.25 squared. Wow! So I have to go back up a line and introduce a number, both adding it and subtracting it. What I need to add and subtract into the equation is whatever 1.25 squared is. I had to check it actually, 1.5625. Okay, here we go. My second line, or my third line, I guess, whatever. X squared plus 2.5x plus 1.5625 subtract 1.5625. Don't forget the negative 0.5 that we had before. Okay, line 1, line 2, line 3. I have my first 3 terms are the same as x plus 1.25 squared. The other 2 go together, sort of like leftovers. So you have 2 subtract 2.0625. All of that had been in brackets when I factored out the 2. And lastly, I'm going to do distributive law because I'm trying to make it look a certain way. I don't want that extra set of brackets. So if I do distributive law, I have 2 times the first, which is x plus 1.25 squared, and then 2 times negative 2.0625, which is negative. Let me just check this thing. So it's negative 4.125. That is as ugly as it gets. We're going to practice some today.